Welcome to Lesson 3.2, where we'll unlock the power of Python dictionaries. Think of a dictionary as your ultimate organizational tool for data. It allows us to efficiently store data as key value pairs, much like a real-world dictionary maps words to their definitions. This structure is incredibly intuitive and powerful. The beauty of dictionaries lies in their ability to access values quickly using unique keys. Instead of searching through a list, you go directly to what you need by its identifier. This makes them fundamental for structured data management in almost any application you'll build. Whether you're managing user settings, product catalogs, or configuration files, dictionaries are your go-to. Ultimately, mastering dictionaries is essential for building robust applications. They provide the flexibility and efficiency needed to handle complex, real-world data scenarios with ease. Let's dive in and see how they work. So, what exactly is a dictionary in Python? Imagine a traditional library's card catalog. Each card has a unique title, the key, and on that card are all the details about the book, the value. Python dictionaries are precisely this: unordered collections of items. Each item within a dictionary is a distinct key-value pair. This pairing is what gives dictionaries their incredible power and flexibility. A crucial rule is that keys must be unique and immutable. You can't have two cards with the exact same title, and once a card's title is set, it shouldn't change. On the other hand, values can be any data type you can imagine: numbers, strings, lists, even other dictionaries. This allows for incredibly rich and complex data structures. Understanding this foundation is key. Let's get practical and see how to create and access dictionaries. The simplest way to define a dictionary is to create it with curly braces, round brackets, similar to sets but with a key difference. Inside, you assign key value pairs using colons, dashes to separate the key from its value, and commas to separate each pair. Once created, you can access values using dictionary key, just like you access elements in a list using an index, but here you're using the key instead. It's direct and efficient. Remember, keys are case-sensitive. Name is different from name. If you try to access a key that doesn't exist, Python will raise a key error, which is something to watch out for. This basic understanding forms the bedrock of working with dictionaries. One of the most powerful features of dictionaries is their mutability, meaning you can change them after creation. To update existing values, you simply reassign a new value to an existing key. Python finds the key and swaps out the old value for the new one. Adding new pairs is just as easy. Assign a value to a new key that wasn't previously in the dictionary. Python will automatically create that new entry for you. This demonstrates that dictionaries are mutable and dynamic, allowing your data structures to evolve as your application requires. For those curious about order, in Python 3.7 and later, dictionaries maintain insertion-ordered keys. This means the order you add items is the order they'll be iterated, which can be useful. Once you have data in a dictionary, you'll often need to process it. Let's look at how to iterate through dictionaries. By default, if you loop directly through a dictionary, you'll get its keys. This is useful when you only need to know what identifiers exist. If you're interested in the actual data, you can use .values to iterate through only the values. This gives you direct access to the information stored without needing the keys. For scenarios where you need both pieces of information, the .items method is perfect for iterating through key value pairs simultaneously. It returns tuples, where each tuple contains a key and its corresponding value. Understanding these methods makes it efficient for processing all data within your dictionary, enabling you to build powerful data manipulation logic. Beyond basic access and modification, Python dictionaries offer several powerful methods to handle your data more effectively. First up is get key default. This method allows you to safely retrieve values. If the key exists, it returns the value. If not, it returns a default you specify, preventing a key error. This is a best practice. Next, pop key is used to remove and return a specific value associated with a key. It's handy when you need to extract an item and ensure it's no longer in the dictionary. The keys method returns a view object displaying all keys, and values gives you a view of all values. Finally, clear comes a straightforward method to empty the dictionary of all its key value pairs. These tools are indispensable for dynamic data management. Let's apply what we've learned to a common scenario managing user data. Dictionaries are perfectly suited to represent user data like name, email, and preferences. Each piece of information becomes a key, and its corresponding value is the data itself. This structure makes it incredibly easy to update specific fields. If a user changes their email or updates a preference, you can modify just that one key value pair without affecting the rest of the profile. Moreover, as your application grows, you can add new attributes as needed, perhaps a last login timestamp or a subscription status. Dictionaries adapt seamlessly. This flexibility makes them ideal for dynamic data models where the structure of your data might evolve over time. It's a powerful way to encapsulate and manage complex entities. Moving to another practical application, dictionaries are excellent for modeling complex objects with varied specifications, like a product. You can structure complex data with nested dictionaries. For example, a product might have a features key, and its value could be another dictionary, containing specific feature details or even a list of features. This allows you to store diverse attributes for a product, from its name and model to its price and a detailed list of features. Accessing nested values directly is intuitive. You just chain the key lookups, like product.features.color. This approach is highly scalable for rich object descriptions, enabling you to model intricate real-world entities accurately and efficiently within your Python applications. It's a powerful pattern you'll use frequently. As we wrap up, let's reflect on the profound impact dictionaries have on data handling. They are fundamental for organizing varied data in a way that is both logical and highly efficient. The key value paradigm is a cornerstone of modern programming. The ability to use key value access ensures efficiency at scale. Instead of linear searches, you get direct lookup, critical for performance in large systems. Their mutability and flexibility makes them flexible for dynamic data models, allowing your software to adapt to changing requirements and evolving data structures. Crucially, dictionaries are not just a Python concept. They connect directly to JSON, APIs, and databases. When you fetch data from a web API, it often comes as JSON, which maps directly to Python dictionaries. Understanding them deeply will make them indispensable.